Keeping track of the natural resources of a country as big as Canada is a phenomenal job. In fact, it's impossible to do with real accuracy. There's just too much country. But what if you had a computer to help? It might work this way. Let's say you wanted to know how many acres of forest had been cut in Western Canada in the last year. You just sit down at your trusty computer, tell it what you wanted, and wait. The computer would sort through hundreds of aerial photographs and satellite images, and in a few minutes tell you just how many acres had been cut. It could also tell you that the smoke from a certain manufacturing plant somewhere was killing a couple of 100 acres of trees, and maybe that a bridge on a mountain forestry road was washed out. No computers can do that yet, but they're not far away. The researchers at the Laboratory for Computational Vision at the University of British Columbia are working on the problem right now. It's a big problem, too. I think we've come to revere computers so much that we even think the really big ones are smarter than us. But they're not. Not because computers aren't wonderful and complex devices. They are. But we're incredibly more wonderful and complex. So complex we don't even understand ourselves. Take sight, for example. Computers can be made to distinguish images, but they don't know what they're looking at. Scientists at the Computational Vision Lab aren't really sure what goes on in our brains when we see, but they have to figure that out so they can teach the computers to see. So far, they've developed a program called MAPC, an artificial intelligence program that tries to mimic the way us humans think when we're looking at something. Let's say they want the computer to recognize a bridge when it sees one. One part of the program contains all the information about bridges. They have two sides, certain shapes, go over rivers and roads, and so forth. When the computer is looking at a satellite picture, and it sees something that has some of the features of a bridge, it then kicks over to a second part of the program that tells it bridges often have rivers running under them, so it should check for a river. The computer does that, and if the information about rivers in its memory matches what it finds on the satellite picture, it will conclude that the first thing it looked at probably is a bridge. This may sound fairly simple, but coming up with the information to put into the computer program can be incredibly difficult. Just what happens in our brains when we see a bridge on a satellite picture? How do we know that's what it is? Until the programmers figure that out very clearly, they can't make the program. Bridges are one of the easy ones. They have a fairly obvious shape. But shapes are only part of the programming problem. Satellites take pictures with infrared cameras. Bright red on a satellite image means healthy vegetative growth, whether forest or crop. Trees under insect attack or suffering from pollution show up darker red. The computer has to be told what color means what. It also has to know that a color on a picture taken over the mountains can mean something very different than if it were taken over water, or even over a city. The whole process is immensely challenging, and the researchers at the Computational Vision Lab are gathering the newest information from fields as diverse as computer graphics to cognitive and perceptual psychology in an effort to teach their computers how to see. It's worth it, too, because computers may not be anywhere near as complex or smart as us, but once they learn something, they'll do it over and over forever. They're fast, they don't have bad days, they don't charge for overtime, and they don't get tired. That's just what we need to keep track of what's happening in a country the size of ours. I'm Noel McNaughton.